Today we're talking about simplifying radicals. Now, radical is just a number that is inside the square root symbol. So something like, say, the square root of 4. Now, what this means when you see something like the square root of 4, if you remember, that's just simply asking you what times itself is going to be 4. So obviously the answer for that is going to be 2. 2 times 2 would be 4. Another example would be, say, something like the square root of 9. That would be 3. But the numbers that we're going to talk about is kind of something what happens when it's not a perfect square. Something like, say, the square root of 48. We're going to talk about simplifying that and how to do it. Alright, so let's take this square root of 48. And what we want to do to simplify it is I want to kind of break this down into factors of 48. Alright, but the factors that I want to use are my perfect squares. The smallest one would be, of course, 4. Then I would be 9, 16, 25, 36, 49. And we can keep going, but these are kind of be the basic or the key ones that most math teachers will ask you to solve. So if I take the square root of 4, that's going to be 2. Square root of would be 3. This one's 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Okay, so I want to find the biggest number that I can, or the biggest perfect square that I can that fits with this 48. And if you can't think of any, you don't have to start with the biggest. You can pick any of these that work. For me, I know that 16 times 3 is going to give me 48. Okay, but what I'm doing is you want to think of this as, okay, this is the square root of 16 times the square root of 3. So the square root of 16 is 4, and then this square root of 3, 3 is a prime number, so I can't factor that out anymore, or I can't fit it into a perfect square where I could take some values out. I can't take a perfect square out, so the 3 just kind of tags along. And so the simplified version of the square root of 48 would be 4 square roots of 3. Alright, let's look at another example. On this one, I'm going to look at the square root of 56. Now, what I want to factor again is I want to look at these perfect squares and let's see if there's anything else I can factor. I'm going to use 4. So if I divide that by 4, that's going to give me 14. Okay, so I got the square root of 4 times the square root of 14. 4 is going to factor, the square root of 4 is 2. Now, if you want to check or if you can't think of anything, you can look and go ahead and factor this 14. That's going to turn into 2 times 7. Okay, that's not going to be any of these perfect squares here. So you can't factor down the 14 anymore. So that's just going to come back down here. And the simplified version of square root, or the simplified radical of the square root of 56 is 2 square roots of 14. Alright, another example is going to be something like this. This is another type of radical where you have a number that's already outside the square root. And so when you're simplifying these, for now, you want to kind of, while you're factoring out this square root part of it, you want to just kind of keep this 2. It's going to kind of keep tagging along. But we still want to do the same thing where I factor using my perfect squares. 18, which is going to factor down into 9 and 2. So square root of 9 times the square root of 2. Okay. Square root of 9 is 3. And then the square root of 2 is just going to come down. Alright, so the question is, well, okay, what do I do with this 2? Well, this right here is 2 times the square root of 18. So when we factor down, it's still multiplication. So I'm going to bring it down. And it's going to be actually 2 times 3 square roots of 2. So to simplify this, we just multiply these 2 outside numbers. That's going to be 6, and then square root of 2. So the simplified radical of 2 square root of 18 would turn into 6 square roots of 2. Alright, the next radical that we're going to look at is kind of well, it's not kind of, it is a fraction inside the square root. Now, what I can do is I can actually rewrite this as the square root of 3 over the square root of 8. Okay, we want to do that. But the thing is that I can't have a square root or a radical in the denominator, you might see it or hear the words rationalize the denominator. And so what that means is that you take this square root of 3 over the square root of 8, and you want to multiply by 1, but not just any one. You want to pick a special one. The one that you're going to use is whatever square root number is down here. That's the number that you're going to multiply the top and the bottom by. Okay, so here I'm going to multiply by the square root of 8 on the top and bottom. Now the reason we're doing that is because the square root of 8 times the square root of 8 is just going to be 8. There will be no radical in the denominator anymore. Okay, so we're going to end up, this ends up becoming 8 in my denominator, no square root. Then I have the square root of 3 times the square root of 8. Okay, now what happens when I multiply these two together is technically I end up getting square root of 24 over 8. Okay, but now I have to look at this numerator and I have to ask, okay, can I simplify the square root of 24? Are there any perfect squares that fit inside the square root of 24? In this case there is. I can factor out the square root of 24 as the square root of 4 times the square root of 6. Okay, and I keep that over 8. 4 times 6 would be 24. 6, again, is not going to be a perfect square. I can't make a perfect square inside the 6. So I'm going to leave it that's as small as I can get this square root of 6. The square root of 4 is going to be 2. So I have 2 square root of 6 over 8. All right. Now that the 2 has come out of the radical, I have to ask, okay, can I simplify 2 over 8? The answer, of course, is going to be yes. I can factor out a 2 out of the numerator and denominator. Okay, so this ends up becoming square root of 6 over 4. All right, for this one, I want to simplify this radical. Square root of 5 over the square root of 6. We can't have a square root in the denominator, so we're going to have to rationalize the denominator. And well, from we just learned in the previous example, I have to multiply by the square root of 6 over the square root of 6. And this ends up becoming 6 in my denominator. Okay. Now, this is going to be square root of 5 times the square root of 6. Okay. Now, before I multiply the 5 and the 6 together, what I can do is look at them separately, individually, and see, okay, can I use any of these perfect squares to make these two terms smaller? I can't, because for the 5 and I can't for the 6. None of these, the 4, 9, 16, those are not factors of 5 and 6. So this is not going to get any smaller. But I can multiply them together. All right, so I get the square root of 30 over 6. All right, we got another radical. This time, if you notice that we have a variable stuck inside this. Now, just a kind of quick thing, remember that x to the third power just means x times x times x. Now, to do that, what we end up doing is we end up looking at pairs. Okay, because that's going to turn in, I could rewrite that as x squared times x. Okay, and so if I take the square root of x squared, that's just x. All right, so let's look at that real quick. So what we want to do, if it helps, you can look at this as looking at two different problems. If I look at the square root of 24, and I want to simplify that, times the square root of x cubed. Okay, so the 24, I want to kind of do like we've been doing, look at these perfect squares and see what numbers can factor. This is going to be the square root of 4 times the square root of 6. Okay, so this ends up being 2 square roots of 6 for the number side of it. Now for the x, or the x to the third power, I want to see how many even pairs I can make, or how many to the second power I can make. Remember that we said x cubed is x times x times x, or technically we could rewrite that as x squared times x. Okay, so what I want to do is I want to look at factoring this as x squared times x, and I want to have these both in the square root. So the square root of x squared is just going to be x. Alright, and then so this here is not going to factor anymore because there's only one x left. Alright, so what we usually do is I can go ahead and combine the outside numbers. I'll put those two together, and then the 6 and the x would just stay on the inside. I can multiply those two together and put them back inside the same square root symbol. So this would be the simplified radical form of the square root of 24 to x to the third power. Alright, I got one more example to show you. Don't forget about this one. It's not as difficult as it looks. What we're going to do, what you want to do, the strategy is to simplify what you can that's inside the radical or the square root first. And so kind of you can separate this out if you need to. Kind of ignoring, see if I ignore the square root just for a little bit, just so you can see a little better. Alright, the 10 over 5, I can factor that out, or I can factor out a 5. That's going to be 2 over 1. Okay. Now, what I want to do here, if I got 4 x's on the top, because remember that means x to the fourth is x times x times x times x. And then on the bottom, if I look at this x cubed, that means x times x times x. So what I'm doing is I can kind of cancel these out, because x over x would just be 1. So I'm marking out however many x's I can get rid of. So there's a pair there, I can cancel out a pair here, and I cancel out a pair here. And so what I'm left with is I'm left with just 1x on the top in the numerator. So what I have, if I cancel out this right here, and I take 3 out of here, I'm going to have just x to the first power there. So the only thing that's going to be left, so all of this stuff right here simplifies out to 2x y to the third power. Okay, don't forget the square root. Now, the only thing that I can simplify, I can't do anything with the 2, I can't do anything with the x. The y to the third power, we can break that down into, remember, y squared times y. Right? And so if I factor this, the square root of y squared times the square root of y, this part is just going to be y, so that comes out. And then the 2, the x, and this y stay inside the square root. There's a 3 that was already outside times this y that came out. And so we would have 3y times the square root of 2xy. So that would be the simplest form, or the simplified version of this craziness right here.